Good morning students. This is Savita, Associate Professor in Mathematics. In today's session, I shall discuss consistency of a system of linear equations. This video is useful for 5th semester BSc students of Mangalore University. Let us understand consistency of a system of linear equations. Consider the system of m linear equations n unknowns. a11x1 plus a12x2 plus etc. plus a1n(xn) is equal to k1, a21x1 plus a22x2 plus etc. plus a2n(xn) is equal to k2. The mth equation is am1x1 plus am2x2 plus etc. plus amn(xn) is equal to km. So we have system of m equations. This is the first equation, second equation and so on. This is the mth equations in n unknowns x1, x2, etc. xn. Now it is required to test the consistency of system of these linear equations. That is, we have to find the solutions of these equations. We have to test whether the solution exists or not. So in order to determine whether these equations are consistent or not, we find the rank of the coefficient matrix and the augmented matrix. That is, we write the matrix A equal to A11, A12, etc. A1n, second row elements A21, A22 and so on A2n, mth row elements AM1, AM2, etc. AMn, and K is equal to, the matrix K is equal to A11, A12 and so on A1n, K1, second row elements are A21, A22 and so on A2n, K2 and so on. The mth row elements are AM1, AM2, etc. AMn, Km. So we have a matrix A which is a matrix of order m cross n, and we have another matrix K which is a matrix of order m cross n plus 1. See, there are m rows. This is the first row, second row and mth row, and first column, second column, nth column. So it's a matrix of order m cross n, whereas K is a matrix of order m cross n plus 1, n plus 1. Okay. Now this matrix A is known as a coefficient matrix and K is called the augmented matrix. We find the rank of the coefficient matrix and find the rank of the augmented matrix. If rank of the coefficient matrix is equal to rank of the augmented matrix, then the system of equations are consistent. If rank of A is equal to rank of K is equal to n, that is the number of unknowns, then the equations are consistent and the solution is unique. That is, there exists only one solution. If rank of A is equal to rank of K is less than n, the number of unknowns, then the equations are consistent but there are infinite number of solutions. If rank of A is not equal to rank of K, then the equations are inconsistent, which means the system does not have a solution. So there are three possibilities. If R of A is not equal to R of K, R stands for rank, R of A is not equal to R of K, the system of equation is inconsistent, that is, it has no solution. If R of A is equal to R of K is equal to n, the equations are consistent and have a unique solution, and a single solution, ಒಂದೇ ಒಂದು solution ಸಿಗುತ್ತೆ. If R of A is equal to R of K is less than n, the equations are consistent but have an infinite number of solutions. How to find the rank? We use elementary transformations, that is, elementary row operations or elementary column operations. Okay, now let us test for consistency and solve a system of linear equations. Let us find whether this system of equations are consistent. If it is consistent, find the values of x, y and z. Okay. So problem is test for consistency and solve. 5x plus 3y plus 7z is equal to 4. 3x plus 26y plus 2z is equal to 9. 7x plus 2y plus 10z is equal to 5. There are three equations in three unknowns. Unknowns are x, y and z. First, let us rewrite the equations in the form Ax is equal to D. Okay. So, A is a coefficient matrix. Its elements are, first row elements are 5, 3, 7, 3, 26, 2. These are second row elements. And the last row elements are 7, 2, 10. Then we have a column matrix x, y, z. That is equal to column matrix again 4, 9, 5. Okay. Now first let us multiply R1 by 3 and R2 by 5. So ಇದೆರಡು equal ಮಾಡಿದ್ರೆ ನಮಗೆ subtraction ಮಾಡುವಾಗ second row in first element 0 ಆಗ್ತದೆ. So in order to make the first element of second row 0, we multiply the first row by 3 and the second row by 5. So the first row operation is 3R1, which gives 15, 9, 21 and 12. ಈ ಸೈಡಿಗೆ ಏನು ರೋ ಆಪರೇಷನ್ಸ್ ಪರ್ಫಾರ್ಮ್ ಮಾಡ್ತೇವೆ ಅದನ್ನೇ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡಿಗೆ ಸಹ ಪರ್ಫಾರ್ಮ್ ಮಾಡಬೇಕು. ಸೊ 15, 9, 21, 12 ಅಂತ ಆಯಿತು. ದೆನ್ ದ ನೆಕ್ಸ್ಟ್ ರೋ ಆಪರೇಷನ್ ಇಸ್ 5R2. 5R2 gives 15, 130, 10, 9 into 5 is 45. Okay. So we have a matrix 15, 9, 21, 15, 130, 10. Third row is not changed, so elements are as it is 7, 2, 10 and then 5. Okay. The next row operation is very clear. It is R2 minus R1. So R2 minus R1 gives 0, 130 minus 9 is 121, 10 minus 21 is minus 11, 45 minus 12 is 33. First row elements and the third row elements remains same. They are unchanged. Now let us make this 7 0. How to make it 0? Let us multiply this element by 7 by 3. So 7 divided by 3 ಮಾಡಿದಾಗ ಇಲ್ಲಿ 15 divided by 3 is equal to 5. 5 into 7 is 35. So I have to multiply R3 by 5. So this element also becomes 35, right? So next row operation is R1 into 7 divided by 5 and R3 is multiplied by 5. Okay. So the next row operation is 7 by 3 R1 and 5 R3. So we have 7 by 3 R1 adaga the first element becomes 35. This is multiplied by 7 by 3, so which is equal to 3 into 7, 21. Okay. And this is multiplied by 7 by 3, 7 by 3 into 21, so 7 into 7 is 49, right? X, and this is 28 because this is multiplied by 7 by 3, so 4 into 7 is 28. This is multiplied by, third row is multiplied by 5, so 35, 10, 50 and then 25. Okay. So the row operations are 7 by 3 R1 and 5 R3 are performed on the matrix. Again, look at the second row elements. We have 121 minus 11 and 33. 11 is common, isn't it? So we perform 1 by 11 R2. That is, we multiply R2 by 1 divided by 11. So the second row elements are changed to 11 minus 1 and 3. Okay. Now look at the elements. If 35 ide, illi so 35 ide. So the next row operation is R3 minus R1 plus R2. R3 minus R1 plus R2. So that is, this element is 0, right? Then R3 minus R2. 21 minus 10, that is 11. 10 minus 21 is minus 11. Minus 11 plus 11 is equal to 0. 50 minus 1 is 50 minus 49 is equal to 1. 1 minus 1 is equal to 0. So here it is, R3 is 10. 10 minus 21 is minus 11 plus 11 gives 0. Here 25 minus 28 is minus 3. Minus 3 plus 3 is equal to 0. See, observe, third row elements are all equal to 0. So first row elements are 35, 21, 49 and 28. Second row elements are 0, 11, minus 1 and 3. Now look at the first row elements. 7 is common here, right? 7 is common in the first row. Therefore, we perform 1 by 7 into R1 because simplification becomes easier. So in the next row operation is 1 by 7 R1, which gives 5, 3, 7 and 4. Therefore, the matrix becomes 5, 3, 7, 0, 11 minus 1 and 0, 0, 0, 4. It is multiplied by 1 by 7. So this element is 4, 3 and 0, right? Now look at this matrix, coefficient matrix. R of A is equal to 2 because third order minor is equal to 0. Therefore, there are two non-zero rows in the coefficient matrix. Hence, its rank is equal to 2. Its rank cannot be 3. Therefore, rank is equal to 2. Consider the augmented matrix. Again, it has two non-zero rows. Hence, its rank is equal to 2. Therefore, rank of the coefficient matrix is equal to rank of the augmented matrix, that is less than the number of unknowns. That is less than the number of unknowns, isn't it? Rank of the coefficient matrix is equal to rank of the augmented matrix. Therefore, equations are consistent, but it is less than the number of variables. Therefore, there are infinite number of solutions. Infinite number of solutions. Yeah. Here we have R of A is equal to R of K less than n. Therefore, equations are consistent but have an infinite number of solutions. So, this set of equations or the system of equations are consistent because the rank of the coefficient matrix is equal to 2, that is equal to rank of the augmented matrix. So, system of equations are consistent. Let us find the solution. How to find the solution? Let us multiply the matrices. 5 into x plus 3 into y plus 7 into z is equal to 4. 0 into x plus 11 into y minus z is equal to 3. Therefore, we have the system which is equivalent to 5x plus 3y plus 7z is equal to 4 and 11y minus z is equal to 3. Now, from the second equation, find y. 11y is equal to 3 plus z, or y is equal to 3 divided by 11 plus z divided by 11. Okay. So, y is expressed in terms of z. Now, here from the first equation we have 5x is equal to 4 minus 5x is equal to 4 minus 3y minus 7z, or x is equal to 4 divided by 5 minus 3y divided by 5 minus 7z divided by 5. Substitute for y in terms of z. So, x is equal to 7 by 11 minus 16 by 11 into z, where z is a parameter. Are you all following? From the second equation, find y. From the first equation, express x in terms of y and z. For y, substitute this value. Simplify, we get x is equal to 7 divided by 11 minus 16 divided by 11 into z. Now, if z is equal to 0, we get one particular solution. Suppose z is equal to 0, we get x is equal to 7 by 11, y is equal to 3 by 11. Therefore, solution is x is equal to 7 by 11, y is equal to 3 by 11 and z is equal to 0. That is a particular solution. Suppose z is equal to 1. z equal to 1 ಹಾಕಿದರೆ x is equal to 7 by 11 minus 16 by 11. Simplify ಮಾಡಿ 7 minus 16 divided by 11. Okay, that is x. Substitute for y. Z the value ಸಿಕ್ಕಿದೆ ನಮಗೆ. Z is equal to 1 ಅಂತ assume ಮಾಡಿದ್ದೇವೆ. So we have 3 divided by 11 plus 1 divided by 11, that is 4 by 11. So z equal to 1, y is equal to 4 by 11 and x is equal to 7 minus 16 divided by 11. That is another value. So we have infinite number of solutions. Hence z is a parameter. Here rank of the coefficient matrix is equal to rank of the augmented matrix, that is less than the number of unknowns. Therefore there are infinite number of solutions. Okay, so we have understood consistency of system of linear equations. So in order to test the consistency of system of linear equations, we find the rank of the coefficient matrix and rank of the augmented matrix using elementary transformations. Okay. Reference book is Dr. B.S. Grewal, Numerical Methods in Engineering and Science with programs in C and C++. I shall stop here. I hope you have understood consistency of system of linear equations. Thank you.